Hello, this is Britt Caswell with another example video. In today's video, we're covering example 2 from section 9-7 in the SavvasRealize Algebra 1 textbook. Today's video is about how to solve a linear quadratic equation by graphing. Kind of a strange way to go about doing it, but we'll get it. So, what they tend to do to solve these systems is they tend to break the equation into two pieces. Alright, so they'll take this part here, this is the quadratic portion, which I'm going to call yellow, and they'll take this part here, which is the linear portion, I'm going to call that green, and between the yellow and the green, we will graph them, and the x values are the values of the equation, or the x values of the interception points. Those are going to be our solutions. So if I write out this yellow equation in standard form, I would say y equals negative x squared plus 5. Now I'm going to think about that in terms of transformations. Alright, so this negative sign is a vertical reflection. And the 5 translates up 5 units. Alright, so starting at 0, 0, I would go up the 5 units. And then this a value of negative 1 tells me when I go one box to the side, I go down 1. Now here's the thing, that's only 3 anchor points, so that's not going to be a super great graph. So I could also, use a table of values, or I could just plug in another number. So if I plug in a 2, I'd have negative 2 squared plus 5, which would be negative 4 plus 5, which would be a positive 1, right? And that can reflect over here to the negative 2. But graphing tends to be a little questionable. Alright, so, there's my very roughly drawn graph. Now the green equation, right, is my linear one. So I have y equals x plus 3, where 3 is the y-intercept. You could also think about that as a translation up by 3, right? So there's our y-intercept. And our slope, well, there's an imaginary 1 in front of that x. So it's rising by 1, running by 1, rising by 1, running by 1. And so if I use my straight line tool, because I don't know how to draw, there we have it. So your solutions are where these two lines cross. Alright, so luckily they had whole number solutions here, right? My anchor points lined up. So the first solution happens at the ordered pair 1, 4. And my second solution occurs at the ordered pair negative 2, 1. Now I need you to understand, the solution is not the ordered pair. I'm going to put that in nice big red text here. The solution is not the ordered pair. Because if you look at the equation that they gave us, the equation that we graphed, I don't see any y values. And an ordered pair contains the y values. So the solutions are only the x values of this expression. So when I go to say these solutions, I'll say x equals negative 2 or 1. And it's not ordered pairs. Might be more clear if I say x equals 1. Alright, so make sure that you're just talking about the x values. Now I'll tell you now, Desmos is probably a nicer graph to do that, but I want to show you guys how to do it by hand also. Alright, so now the try it just has us do it a couple more times. Alright, so flipping up some colors, I'm going to call this one the blue one. Alright, that's our quadratic equation. And we'll do yellow. I like blue and yellow. So if I'm considering the quadratic equation, I have y equals x squared plus 1. So that plus 1 is a translation up by 1 unit. So if I start at 0, 0, I go up 1. The a value is 1, so when I go to the side by 1, I go up by 1. Then normally our next point would be at 2, 4, so if I scoot that up 1, I go to 2, 5. And there is our not well drawn parabola. Oh, it was almost good. And then we go to our linear equation. I have y equals x plus 3. So that 3 is our y-intercept. It's a translation up by 3. So 1, 2, 3. And the slope here again is 1. So that means that I rise by 1 and run by 1. And so yet again, we're faced with a situation where we have this nice whole number solution. Notice that some of my anchor points overlapped each other. So I have an intersection point right here and here. And if I look at those x values, my two solutions are x equals -1 and x equals 2. Alright, then we have one more. Ugh. This one is quite yucky. To be honest with you, I'm not a fan of it because it has those decimals in there. Yucky, yucky decimals. So we'll try our best. Graphing with decimals is often hard to do. And so what I tend to do is I tend to convert my decimals to fractions because fractions are something that I'm a little more comfortable with, but also it helps out, for example, with the slope. Okay, so I'm going to start with the quadratic like I have been. So that -0.5, I'm going to call that -1/2. And then we have a +5 here. Remember that minus sign is tied to the x squared. It's not tied to the 5. That's why I call it a -1/2 x squared and a +5 because this 5 is positive. Alright, so looking at this in terms of transformations, this is saying to go up 5 or translate up 5. So I'm going to put it here. And then the a value of -1/2 means that when I go to the side by 1, it falls by 1/2. So this is a vertical compression. And the negative, of course, is a vertical reflection. That's what flipped it upside down. But getting my other anchor points, that's ooh. So take a look at one that didn't have a compression or a stretch. Notice that from this anchor point to this anchor point, the graph went up by 3 units. So if I have compressed this by 1/2, then instead of it changing by 3 units, it's going to change by 1.5 units, which is half of that. Which gets me another anchor point. Oh, that's only 1 unit. Silly missy. So that gives me another anchor point, 1/2 and 1 unit down there. And then after that, I'd kind of have to figure it out. What I'm going to do is I'm going to kind of draw the U shape and pray that one of the anchor points that I used is a valid answer. Is that a good way to go about it? Not really, to be honest with you, but that's what I got, alright? So now the linear component, I have y equals 0.5, or -0.5, so I'm going to call that -1/2 x plus 2. So that means I have a y-intercept of 2, so I go up by 2. And a slope of -1/2 means I fall by 1 and run by 2. Fall by 1, run by 2. Alright. So if I use my straight line tool, well, one of my anchor points lined up. That was great. So I definitely know for sure, 100%, that x equals -2 is a valid answer. Over here is where it gets a little questionable, right? Because I didn't have an anchor point that I put over here. I could try to calculate it. I could say, well, what if it is intersecting at 3? And I could see if 3 works on both of the graphs, something like that. I don't know. But I'm going to say x is approximately 3-ish, because my drawing here is very unclear. So if I'm really desperate, I can go to Desmos and I can use Desmos to help me in order to draw that graph. Alright, so I just took a snipping tool of the question so that when I do go to Desmos, I can see the equation. There we go. And so I'm going to show it to you in two ways. First, I'm going to show it to you graphed separately like I've been doing. So I have the negative 0.5 x squared plus 5. I think I had called that blue, but I'm not going to change the color on it, I don't think. And then on the other one, I have y equals negative 0.5x plus 2. These colors are going to annoy me, so I'll fix it. Alright, there it is. So there's our kind of graph there. So there's the negative 2 that I saw first sharesies, faux realsies. And look, 3 did end up being an answer. But it wasn't an answer because I could see clearly that it was an answer. It was maybe my drawing was somewhat good enough. Okay? Now Desmos has another kind of cool feature on it. I'm going to mute these guys. Where if you just type the equation as you see it, it'll actually solve it for you as well. So equals negative 0.5x plus 2. So when I do it this way and I type in the equation like I see it here, take a look at that. These two vertical lines are the two x values that we had just gotten, negative 2 and 3. So depending on what tools you have available to you, Desmos is a great way to get a quick answer. Just make sure that the answer is coming from this kind of understanding here. But do we usually solve things by graphing? Absolutely not. So there we have it. That is example 2, solving a linear quadratic equation by graphing. Until next time.